Hello everyone, welcome to MV Tutors. I'm Tsolo and today I'll be covering with you the quadratic sequence. Okay, let's just get right to it. Before we even cover the theory, I just wanted to look at a question so that while we're doing the theory, you can sort of in a way answer those questions yourself. Alright, given the quadratic pattern 5, 10, 17, 26, and so forth, write the next two terms of the pattern. And then the second question, determine the formula of the nth term of the pattern. And the third question, which term of the pattern will have a value of 1765? Okay, then we have a second part of the question, a quadratic sequence with general term Tn has the following properties. So the 11th term is 125, and then Tn minus 1 is equal to 3n minus 4. So just have that in mind and let us go on to do the little bit of theory. Okay, so what is a quadratic sequence? Remember on the video of arithmetic sequence and series, what I told you the difference between a sequence and a series is, if you can't remember, you can go back to it. But the quadratic patterns, we don't cover the series part of it, okay? There is no sum formula for the quadratic pattern that you cover at this level, maybe at a varsity level, I'm not sure. But here we're only dealing with the sequence, not the series, okay? So questions that you're gonna get are just covering the sequences, not the series. So what is a quadratic sequence? Okay, a quadratic sequence is a sequence that has a common difference in the second row. Okay, this is the first row, or we say the first difference, and that is the second row, which we call the second difference. All right, so I'm just going to write down what a quadratic sequence is. Okay, so a quadratic sequence is a sequence that has a common difference in the second row. Or you could say it has a second common difference. Okay, and having a look at, this is our nth term formula. This is the general formula for a quadratic pattern. Remember I said if you get a quadratic pattern, think of a quadratic function or a parabola. Okay, a parabola that would have, if a, for example, is positive, okay, then you have a smiley face parabola with your local minimum there. Okay, and if a is negative, then you have a sad face parabola with the turning point there being your local maximum. Okay, it's better to just visualize it in your mind, because sometimes they will ask you questions pertaining to the local maximum and minimum. All right, so that is the general term formula. And if you were to take that formula and substitute 1, you would get a plus b plus c. If you were to substitute 2, you would get 4a plus 2b plus c. If you were to substitute 3, you get 9a plus 3b plus c, and so forth. All right, so normally when you have a quadratic sequence, they give you 4 terms. Okay, because when you get your first difference, you realize actually when you look at your first difference, it is like an arithmetic sequence. Okay, It's something you can note. It's arithmetic sequence. Arithmetic sequence. Okay, so yeah, and then you get your first difference, all right? Then you can get your second difference, and you see that your second difference is equal or is common. So that is why we say our quadratic sequence is a sequence that has a second common difference. All right, so that is quite important, all right? Just extra info, but when you cover cubic functions, okay, you learn something called the derivative. So a cubic function would look something like this, or maybe, let me rather draw a nice one. Ooh. Okay, so maybe let's say you have a cubic function, all right? If you were to derive, okay, or to differentiate that cubic function, you would end up with a parabola, okay, a quadratic function. If you were to get the derivative of a quadratic function, you would get a straight line, okay? So yeah, just looking here, basically, this is your quadratic function, okay, function, and that would be your linear function, okay. Ooh. Right, and this quadratic function that can present your quadratic pattern, okay, that's I say whenever you think of quadratic patterns, think about the parabola itself. So this is equivalent to a quadratic pattern or sequence, and this linear function would be like your arithmetic sequence or series. Okay, just gonna say pattern. All right, so yeah, that would come in handy if you're thinking about it. So like here, if you have a look, so you have your terms there, let's say the first four terms, and then once you get the first difference, that gives you your arithmetic sequence. And if you have a look at the second difference, then you have your common difference. All right, and then yeah, that's the main thing about the quadratic function, pattern or sequence. Okay, and then practical example, remember for the arithmetic sequence, I told you that practically it's like when you are stacking something up. So if you were to stack some cards in a form of like a 2D pyramid, okay, I'm just going to use a similar example. So let's say you have also cards to stack, okay, for the quadratic pattern, quadratic sequence. So yeah, let's say you had in your first, you had a card to stack. So there are 3 cards there. And then again, you had to stack to the second row. Okay, so cards here, that would be 3, okay, and the cards here, it would be 3, 4, 5, 6, 7, 8, 9, okay, and then you have some cards to stack 3, okay, obviously they would touch each other, so don't mind my weird sketch. Okay, yeah, they are touching, guys. Just imagine them touching. All right, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then for, like I said, quadratic pattern, you want 4 terms that you're looking at, if you may. If you just have 3, you won't really see that as a quadratic pattern, okay? And then lastly, well, let me just rather do it like this. Maybe that would be better. Okay, have the first row, second row, third row. Okay, so here you have 1, 2, 3 cards. Okay. Okay, so the number of cards 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 30. So you have 30 cards here. Alright, so if you were to get the first difference, see I have 6 here, I have 9, and I have 12. And then the second difference would be 3 and another 3. Okay, so if maybe you're playing a competition and they're like, how many cards do you need if you were to stack 60 rows? Okay, so this is where this would come in. you can formulate a quadratic formula from the nth term formula that we just saw, and you would then calculate if you were to require 60 rows, so many cards would be expected. Okay, so that is like, yeah, the practical application. But yeah, let's go back to the question. That is pretty much it. The theory part, that is. Okay, and as I said, there is no series, so there won't be any sigma notation. You won't be having any sum term formula or anything like that. Okay, so let's just go to the question. All right, or question. Okay, so let us have a look at the first question. So we have a quadratic pattern 5, 10, 17, and 26. And the first question says, or 2.1.1, it says, write down the next two terms of the pattern. All right, so I'm just going to write it out. It is 5, 10, 17, 26. And like I said, normally if you in an exam they don't tell you you have a quadratic sequence, if they give you 4 terms then you must somewhat think, okay, I think I have a quadratic sequence here. Okay. Because if it's arithmetic or geometric, you just need 3 terms. All right, so here we have 4 terms, but anyway they told us it's quadratic. So anyway, yes, now we're getting the first difference. So if you say 10 minus 5, I would get 5. If I say 17 minus 10, I get 7. And then 26 minus 17, I get 9. So what I want you to realize about the first difference, okay, remember this is the first difference, is that for you to get the terms in the first difference, maybe let's look at 5. I had to take the second term and subtract the first term. Okay, so basically I'm taking Tn minus 1. And remember what I said while we're covering the theory, that the first difference actually, it gives you your arithmetic sequence. Okay, so that is very key. Okay, it gives you arithmetic sequence. So yeah, that is the first difference. Now if we go to the second difference, again applying this Tn minus 1. So 7 minus 5, you get 2, and then n9 minus 7, that is 2. And that is your second difference, which is common, which is what we are expecting. Now they want us to write down the next 2 terms. So if I see the trend here, it's 5, 7, 9. I'm expecting 11 and 13 as well. And if I look at the difference between those two, I still get 2. So what is 26 plus 11? That would be 37. Okay, and then what is 37 plus 13? I will get 50. Okay, so to officially write down the answer, 2.1.1, it is 37 and 50. Those are the next 2 terms. All right, and then we have to determine the formula for the nth term of the pattern. All right, So 2.1.2. Remember the general term formula? It is an squared plus bn plus c. Now, the important terms that you are going to look at here is 2, first of all, okay, and then 5, and then 5 again. Why is that? Because if we look at, when we were covering this here, okay, let me just remove all of that. Okay, so we're gonna equate 2 to 2a. You see, we're looking at these numbers over here, okay? So we're gonna equate 2a to 2, and then we're gonna equate 5 to 3a plus b, and then we're gonna equate 5 again to a plus b plus c. All right. So yeah, so 2a is equal to 2, therefore a is equal to 1, okay? And then secondly, we said 3a plus b is equal to 5. So we know a is 1, so I have 3 plus b is 5, and then b is 2, okay? And then lastly, a plus b plus c is equal to 5. All right, so I know a is 1, b is 2. Okay, so therefore c is 5 minus 3, which would be 2. Okay, so finally I can write down my general term equation. I'll have n squared plus 2n plus 2. And guys, this is where you want to now check. You can't just get an answer and be happy and move on. You need to check whether this equation is correct. Okay, so let us say we know our third term, maybe our fourth term. Our fourth term is 26, right? If we were to substitute 4 in this formula, will we get 26? Okay, let's see. So if I have 4 squared plus 2 times 4, which is 8, plus 2, I'm getting 26. So let's check if we were to check the fifth term or the sixth term, because we had to get the rest of the other terms, or to the next 2 terms. So if I were to use 6, so 6 squared plus 12, 2 times 6, and then plus 2, 50. So yeah, I am confident the fourth term was 26 and the sixth term was 50. So I am confident that my equation is right. And then the third question, it says which term of the pattern will have the value of 1765? Okay, 1765. So if I were to use my term formula, okay, what number term would give me 1765? So I have n squared plus 2n plus 2. Okay, here you're going to use the quadratic formula. All right, so I'm looking for n, which is equal to minus b plus minus b squared minus 4ac all over 2a. Okay, if I were to rewrite this equation, it would be n squared plus 2n. Now, 2 minus 165 will be negative 1763. Yeah, 2 minus 1765 will be negative 1763. Okay, so let me just substitute. So in the place of b, I have 2, so that will be negative 2 plus minus. I have 2 squared, which is 4, and then 4. A is 1. C is negative 1763. Generally, if you have such a big number, you are expecting C to be negative. If C were not to be negative, then this, you wouldn't have any roots. Okay, so 2A, yeah, and let's just plug this in the calculator and get the values for n. Just a recap, remember n can only be positive, and it can be a whole number, not a decimal, not a fraction, not a negative number. Okay. So we have negative 2. I'll start with the plus. And then I have 4 minus 4 times negative 1763. Okay. And at the bottom we have 2. So I get an answer of 41. Okay. Okay, so I have 41, or because the quadratic formula, I'm expecting 2 solutions. So if I were to have a negative there, I have negative 43. Okay, so clearly this is not the solution, and then we would need 41 terms in order to get to 1765. Okay, and that is the last question for question 2. We're going to look at that bonus question. I'm just going to pause to bring the question down quickly. Okay, so this last question we're doing, it says a quadratic sequence with the general term Tn has the following properties. So the 11th term is 125, and if you take Tn minus 1, you get 3n minus 4. This is like a straight line. Remember, if you have the equation y is equal to mx plus c, this is exactly that way. So I know that is my first difference. Okay, it's talking about the first difference. And I know the first difference is an arithmetic sequence. Okay, so now determine the first term of the sequence. Alright, I'm gonna start like this. We'll see how it ends up. So the 11th term is 125, right? If I were to take this equation that they gave us, if I were to say T11 minus T10, okay, that would be 3 times 11 minus 4. So that would be 33 minus 4, that is 29. Okay, so basically if I have my 10th term here and I have my 11th term there, maybe let's also see the 12th term. Okay, if I were to get whatever that 10th term is, I know the 11th term is 125. Okay, so the first difference there would be 29. Okay, and then I would say 125 minus 29. Okay, I'm not going to calculate that in my head. Okay, so 125 minus 29. So I know the 10th term is 96. Okay, out of interest, I'm going to get the 12th term and the 13th term. Okay, so if I were to get the 12th term, sorry, it should be the 12 minus the 11 would be 3 times the 12 minus 4. So 3 times 12, that's 36. 36 minus 4, that is 32. So now the difference between these two is 32. Okay, and if I say 125 plus 32, 125 plus 32, I get 157. So the 12th term is 157. Okay, and if I get the 13th term, it's based, or rather, let's just put it like this. If I look at T13, so that would be 3 times 13 minus 4, that's 35. Okay, so 35 is there, and if I have 157 plus 35, 157 plus 35 is 192. So the 13th term is 192. Okay, you didn't really have to do all of this, but I just wanted to see what is happening here. And if I look at the difference between 32 and 29, that is 3. Between 35 and 32, that is 3. So at least I know that my second difference, which is the common difference, is actually 3. Okay, and remember, according to it's so up there, but I'll go. If I look here, your common difference all the time is 2a. Okay, so I can already determine what a is from this. Okay, so 2a is equal to 3. So a is 3 over 2, or 1.5. And why am I doing this? So my strategy is this. I want to get the term formula, the general term formula. Once I have that, I can then substitute 1 to get what the first term is. That's what I'm really aiming for here. Okay, so to get a, it's fine. 2a is equal to 3. But if I have this term here, I can't say 3a plus b is equal to 29. That would be incorrect, because 3a plus b, I'll go back up again and I'll show you. And I also can't say a plus b plus c is equal to 96, because these here are for when t is equal to 1. But here I have, it's where n is equal to 1. Okay, that is where n is equal to 1. But for this row here, whatever, do we even call it a row? This diagonal column, I'm dealing with n is equal to 10. So if I want to use this, I need to get what n is equal to 10, what the Tn formula is going to look like. Okay, or I could go for 11. It doesn't matter, but I need to know that this is n is equal to 10, and that is n is equal to 11. Okay, so whether you take 10 or whether you take 11 is really up to you. I'm going to use 10. You can try at 11. We will get to the same answer. So I have a here already, but let's just ignore that for now. So remember, the general term formula is an squared plus bn plus c. Okay, if I substitute n is equal to 10, I'm going to get 100a. 10b plus c. Okay, that is for T10. All right, actually I'm going to have to do for T10, T11 and T12. Okay, so yeah, let's just do T11. That would be 11 squared, that's 121a plus 11b plus c. I actually think I need those two only. Okay, so if I have 100a plus 10b plus c, and then I have 121a plus 11b plus c, so the first common difference, so 121 minus 100, I'm gonna get 21a, and then 11 minus 1, that would just be 1, and then the c cancels. So 21a plus b, guys, that would be equal to 29. Okay, we already have a. 2a is equal to 3. Okay, and then now we have that 21a plus b. Okay, that would be equal to 29. Ooh. That is equal to 29. So I can work out what b is. Okay, I have a, like I said, it's 1.5, 3 over 2, and then plus b is equal to 29. So b would be equal to 29 minus 21 times 1.5. Okay, so b is negative 2.5. Negative 2,5, or I could say negative 5 over 2. Okay, so I have b, and now I'm left with c. So for c, I can use this. Okay, so it would be 100a plus 10b plus c is equal to 96. Okay. All right, we have a is 1.5. We have b, negative 2.5. And c is 96. Okay, so, plus c is equal to 96. So if we're going to solve for c, okay, I have 96 minus 100 times 1.5 minus 10 times negative 2.5. Okay, and my answer is negative 29. Negative 29. So basically, my general term formula is 3 over 2 n squared minus 5 over 2 n minus 29. And before I get excited, I'm going to test it, okay? So I'm going to test for T13 and T11. Okay, we know T11 was given to us, it's 125. All right, and T13, we also tried it, it's 192. So we're expecting 192 for T13 and 125 for T11. Okay, so let us see. So 1.5, I'm gonna say 13 squared, right, minus 2.5, 13 minus 29. All right, guys, we're getting 192. Yay. And then T11, 125. So great, our formula works. Okay, awesome. Now, what we've been waiting for, or looking for, or what was asked, they want to know what the first term is. So that's 3 over 2, 1 squared, minus 5 over 2, 1, minus 29, and T1 is equal to negative 30. Okay, so this sequence started on the negative, and by the time it reached the 11th term, it was positive going forward. And yeah, guys, we're done. So the first term is negative 30, and that's it. Okay, I hope you enjoyed the lesson. I hope you learned something. If you have questions, if you want to have sessions with us, please visit our website. There you'll have our contact details, our email address, our telephone numbers, or cell phone numbers rather. Contact us. We'll be happy to help you. And yeah, please like this video and subscribe to our channel. Thank you.